Hello everyone, I was asked on the forum if I would do a video to show how to debug scripts in Auggie. So this will be a short run through to show how you can do that. As an example, we will run a command here which is going to fail. Here's an M7 command in my single line MDI. I'm going to run the command and you can see over here in the window I got a sound for an error and it says program stop, script killed. And if we look inside the log, we can see our bottom error here is the script set_missed_flood was called. That script, incidentally, is inside the G-code library, but something in it attempted to call a non-function type and it crashed. So the question is, how would you troubleshoot such a thing? Well, first of all, we're going to turn on the scripter, because when you turn on the scripter, all of your scripts are recompiled, retaining their text in a debug mode so that you can more easily see what's going on. So we'll turn on the scripter with power up, and then we'll try that same command again. I'm going to go over here to the single line window. I'll zoom this up so you can see it. I'll put it on the M7 command and hit run. And you can see that the screen opened up in a purple screen. And this is because it sensed an error and it knew we were in debug mode. So it gave us the script that failed. But of course this script is made up of a lot of functions, so it's hard to tell where exactly it failed. Okay, so this opened up to a blue screen, and the blue indicates that we're in a debug mode. And if we look at the state of our threads over here in the corner, in the middle, we have thread 18 which is blocked. And if we click on it, it takes us to a hypotenuse and get angle function. This is just a function that's running in the background doing our polar. So we can ignore that. If we click on the second one, which is thread number 30, let's say that it's broken, and here it will tell us we have a problem with the line. You can see that the arrow is pointing at the line which is broken. At this point you could try to single step, but it's already broken, so it means that the script is pretty much dead. So this tells you where to look for your problem. Here I've got an X trying to change itself to a float, and I think it's doing it incorrectly, so we'd want to fix that. Well, we can see that this is inside the G-code library. So the purple X button up here, kill all threads, will kill that and take us back to our main screen. So now I'm going to hit the live button over here and check out that G-code library and hit local edit. And now it'll pop up here in our scripter. And if we go down to that function that we were at, set_missed_flood, I'm going to get rid of that X float. This is just a line that I typed just as a test. This code here is normally not in the code. But you might want to look at this code as it executes, because that's one of the nice things about a debugger is you can execute things one line at a time. In order to do that, you can put a debug statement, just a debug function call like that. Now, whenever the program sees this debug statement, it will break into the scripter if the scripter is open. You would actually be free to leave that in there in your runtime scripts, but it will annoy you when you are debugging something else, because anytime it hits the debug statement it will break back into that script. So I'd advise only using them when you're debugging code. So now that I've changed that code, I'm going to run it just to see if it compiles, and it does. And then I'm going to check it back into the library. And it says it's checked back in, and you can see it disappears. Now, I didn't necessarily have to check it in. I was just showing you really the process. At the moment, we're just simply in a debugger. So now we have two choices. We could either run that M7 again in order to call flood missed, or we could simply command it with a set_missed_flood 0, since that's the command that it was failing on. And if we run it, we'll get our warning because we haven't checked out any scripts. That's fine. And when we run it, you can see that we come to this blue debugging screen again. Now, it won't necessarily show you where it's at until you click on the thread itself. And in this case, you can see it's the top thread, thread 29. If I click on thread 18, it takes me to that polar loop thread, which again is just taking care of changing the coordinates on the polar display whenever we jog. So it gets called periodically on a motion update command. So we can ignore that and just click on thread ID number 29, which will take us back to the thread that we were looking for. And you can see that we stopped on the set_missed_flood on our debug statement. Now the debug statement again would be ignored unless the scripter is open. But because we tried to execute this function, whether through an M7 or through calling setMistFlood, it will break on the debug. Now when it breaks in and you're to the arrow here showing the line that it's on, you have a variable window over here which will tell you things about your variables. For example, it knows that there is a variable named x and y, and you can see them in the loops here. Until you get somewhat advanced, you won't need to know anything about this or state. State is just simply what's coming in. If I had called this function with a 1, state would be 1. So it's just showing us the value of that variable. So state, x, and y are all useful to us. This pointer you don't need to worry about for now. Now you can single step through this with the single step step into up here, and you can see that it steps a line. Sometimes you have to push 2 or 3 times because a single line of text could be 3 or 4 machine code commands, and you're going to have to push that for each one. But you can see we stepped through the print, and down here at the bottom it printed the line that line was doing. And now it tells us that the x is null and the y is null. That's because they haven't been assigned yet. If we take one more step, you can see x is now changed. It is an integer with the value 0. And now as we step, it will keep on stepping through. Now, if you don't want to keep having to push step, don't use step into, use step over. As you can see, I called a function up here called setRotation, and by going step into, I stepped into the setRotation function. If you use the second button, which is step over, a single click will take you from statement to statement. The step out button would step out of the function. In this case, it would take us back to where we started, where we commanded a setMistFlood. Now, as long as you're in a purple screen, you can't edit. In order to get back to editing, push the X button, and that'll take you back to where you were. So that's a quick example of how you debug. You can use a debug statement. I advise taking it out afterwards, but you can pepper your code with them as well if you like. It's also a smart idea to put print statements when you're checking things out, because you can always use this window down here to print results and see what's happening on variables that may not show up in your variable window. Globals will not show up here, just locals. So if you need to see the value of a global, use a print statement. Okay, that's it. I just want this to be a quick example of how to debug things. Incidentally, this is true only as of version 1.2, which is online now. The library had screwed up the debugging slightly, and that's been repaired. So download version 1.2 and you can repeat everything that I just did here. Thanks a lot.